Okay, so now that we have seen a little bit about integers, I want to speak a little bit to rational and irrational numbers. Okay, a rational number is simply just any number that we can think of as being written as a fraction. Okay, or specifically, we have here a ratio a over b, where a and b are both integers. So some number that can be written as a fraction, or the numerator, the number on top, is an integer, and the denominator, the number on bottom, is also an integer. Okay, so let's look at a few examples here. Okay, so we can have our normal fractions, right? So we have 1/2. We can have 3/2 as well. These are both good examples here. Just normal everyday fractions. Okay, we can also have integers like, say, 3. And the reason we can have something like an integer, say 3, is we can also write 3 as 3 over 1. This is because 3 divided by 1 is just 3. We can write 3 as either 3 or 3 over 1. So this could also be written as a fraction. Okay, if we have something like a terminating decimal. So for example, we have the number 1.3. This is a decimal that terminates, it stops, meaning we just have 1 point and then just 3, or just any finite number of numbers after the decimal place. We can write this as, say, 13 over 10. So we can also say that this is a rational number. Probably a little bit more weird to think about is something like a repeating decimal. Okay, so maybe an infinite repeating decimal. So for example, we write 0.3 with a little bar above it as 0.33 and so on. And what we can do here is we can actually just go ahead and say, since this decimal goes on forever, we're just going to go ahead and call this 1/3, okay? And this is only because we have an infinite repeating decimal here. So we can call this a rational number as well. Okay, so let's take a look at some irrational numbers. So the best way, I must have erased my definition here. So we have any number that cannot be written as a fraction, we'll say. Okay, so if we're not able to write the number as a rational number, right? We call it an irrational number. Okay, so we can say a lot of the more common examples of this are numbers like pi or e. Okay, these are numbers that you're going to maybe see pop up a little bit later in this semester. Hopefully, we've all seen pi before. E is another number like it. Okay. Used for different purposes, but it's also an irrational number. Okay, we can also say that something like the square root of 2 is an irrational number as well. And this is because it's not a perfect square. So anytime we take the number, we take the square root of a number that isn't a perfect square, we're gonna this is an irrational number. So for example, let's take the square root of 4. Square root of 4 is just 2, so we would call that a rational number. So it really has to be a non-perfect square here. Okay, and we can also say the product of some non-zero integer and another irrational number is also rational. So we could have something like 2 times the square root of 3, or we could have something like 3 pi. Okay. So these are examples of irrational numbers. Okay, so there's no way to neatly write it as a fraction. I guess you can define it by by what a rational number is not, I suppose. Okay, so let's do a couple of examples here. So the goal here is to identify each of these as rational or irrational. Okay, so we'll put a check mark if it's rational or irrational. So let's take a look at the square root of 36, okay? Well, the square root of 36 is just 6, okay? And this is because 6 times 6 gives us 36. So we can write the square root of 36 as an integer, or if we want to, we can write it as a fraction as well. So I suppose we can call this a rational number. Okay, so let's take a look at negative 4 pi. Well, we just previously said that if we have a a irrational number multiplied by any non-zero integer, we say that it is an irrational number, and we already defined pi to be an irrational number, so we're going to call this an irrational number. 11 over 10. Now, 11 over 10 is already written nicely as a fraction, so this is just simply a rational number. Okay? How about negative square root of 3? Well, anytime we see negative some number, maybe that's not an integer, we can think of multiplying that by -1. And we know that the square root of 3 is an irrational number because it's not a perfect square. There's no number that we can multiply by itself to give us 3, other than the square root of 3 that we have defined here. So we're going to call this an irrational number. Okay, and the last one, probably the trickiest, is 40.9 repeating. So we can also write this as 40.999, so on, right? And so what we're going to do anytime we see something like this is we're actually just going to go ahead and round it up. And we're going to take a little bit of a logical leap here, and we're going to say that this is really the same thing as 41. So we're going to define this as rational, okay? It's really not 41, but it kind of is 41. However you want to think about it. But either way, we define this as a rational number, okay?